Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift into sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing soften, and your body become comfortably heavy against the bed. Because tonight, we're not just closing our eyes, we're traveling between the stars. From the earliest dreams of interstellar wandering to the gentle physics that shape the space between suns. From imagined vessels drifting through the dark to the soft glow of distant, unknown worlds. We'll explore 100 sleepy facts to help you relax, unwind, and drift deeper into the night. Interstellar travel can seem impossibly vast, yet when spoken slowly, when pictured in the calm darkness of bedtime, it becomes something soothing, like an ocean we are just beginning to understand. And as we follow its quiet currents, you may feel your thoughts settling, your breath deepening, your body growing loose and peaceful. If these calm explorations help lull you into sleep, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, let the day fade away, and let's begin our journey through the gentle, endless space between the stars. Fact 1. The ancient wish to wander. Long before we understood what stars truly were, humans looked up at the night sky and felt a quiet pull toward them. That gentle tug, part curiosity, part longing, became one of our oldest dreams. Even without telescopes or science, people sensed there was more beyond the fragile circle of firelight and the boundaries of their world. As centuries passed, we slowly learned that these distant lights were suns, each one a beacon in an immeasurable ocean. The idea of traveling to them felt like poetry, something meant to inspire rather than to accomplish. Yet the dream stayed with us, drifting from generation to generation, like a soft whisper passed through time. And from that whisper, the journey begins, quietly and full of wonder. Fact 2. When the night sky first called us, there is something deeply soothing about the night sky, a calmness that seems to settle over the world as soon as the stars appear. Early humans slept beneath open heavens, and the slow turning of constellations became a kind of lullaby. Patterns formed, stories grew, and in the dark, our ancestors imagined pathways between the stars long before they knew what those lights truly were. This quiet sense of connection shaped mythology, guided migrations, and helped the earliest travelers cross oceans. In a way, the night sky taught us how to journey. It gave us a direction to follow, a map that glowed softly above our heads, inviting us to wonder what lay beyond. Even now, that same gentle invitation remains, waiting just beyond the edge of twilight. Fact 3. Understanding the space between suns. When we talk about traveling to another star, we're talking about crossing a vast, serene wilderness, a place where distances stretch so far that even light itself takes years to drift across. The space between stars isn't empty. It's filled with a thin, ghost-like mist of atoms, drifting quietly through the dark. This interstellar medium is sparse, softer than any vacuum we can make on Earth, yet it shapes everything about the journey. To cross it is to move through a realm of near silence, where a starship would glide for decades or centuries with nothing but starlight for company. It's a space that asks for patience, for gentleness, for a kind of slow courage found only in long dreams. And beyond this delicate ocean of nothingness, the next fact waits softly in the dark. Fact 4. How far a light year truly feels. A light year is often described as a distance, but it's also a feeling, a reminder of how gently and patiently the universe moves. Light, the fastest thing we know, takes an entire year to travel just one of these cosmic steps. In that time, Earth circles the sun, seasons turn, lives shift, all while a single beam of light glides steadily through the dark. When we imagine interstellar travel, we are imagining journeys across dozens, hundreds, or thousands of these light years. It's a scale almost too large for thought, yet strangely comforting. It reminds us that space isn't rushed, it isn't hurried, it simply stretches out, calm and unbothered, waiting for us whenever we're ready. And beyond that measure of distance lies another quiet truth of space. Fact 5. The quiet ocean of the interstellar medium. The space between stars might seem empty, but it holds its own soft tapestry of matter, a faint ocean of atoms and dust drifting through the dark. Imagine the calmest sea you've ever known. Then imagine removing almost every drop, leaving behind only a few wandering molecules. That's the interstellar medium. Thin, delicate, almost unimaginably sparse. Yet this gentle mist carries the history of stars. Every grain of dust, every lonely atom once belonged to something bright, the breath of a dying sun, or the ashes of an ancient explosion. As a starship travels through this space, it moves through the remnants of cosmic generations, passing through the quiet memory of long-gone worlds. And deeper still, gravity shapes our journey in ways we rarely notice. Fact 6. The gravity wells that hold us close. Before humanity can travel to the stars, it must first climb out of the gravitational embrace of its own home. Planets and stars shape the fabric of space like deep, smooth wells, gently pulling everything toward their centers. Earth's gravity is comforting in daily life. It's what keeps our feet on the ground, our oceans in place, our world steady beneath us. But for a spacecraft, escaping gravity is the first great act of interstellar exploration. It's like rising from a soft valley, lifting slowly toward open sky, leaving behind the warm pull of home. Only once we climb free can the true journey begin, unfolding into the vast, quiet dark beyond the sun's reach. And from that escape, we drift toward the edge of our solar neighborhood. Fact 7. The boundary of our solar neighborhood. As we travel outward from the familiar warmth of the sun, we eventually reach a place where planets grow sparse and sunlight grows faint. This region, far beyond the orbit of Neptune, is where our solar neighborhood begins to soften into true interstellar space. Here, the sun is no longer a bright presence, but a distant lantern, shining with a gentler glow. This boundary isn't a sharp line. It's more like a fading memory, a gradual thinning of solar influence. Objects here move slowly, following long, quiet orbits that can take centuries to complete. It's a place where stillness feels almost complete, where a starship would glide through shadows older than human history. And beyond this dim frontier lies the sun's final breath. Fact 8. Where the sun's breath fades away. The sun doesn't just shine, it exhales, constantly. A steady stream of charged particles drifts outward in all directions, creating what we call the solar wind. Near Earth, this wind can stir auroras and shape magnetic fields. But as it travels outward, it weakens, becoming softer and thinner until, eventually, it can no longer push against the surrounding galaxy. This place, where the sun's breath meets the winds of interstellar space, is known as the termination shock. It's a quiet boundary, not dramatic or violent, but gentle, a place where the rhythm of our star slows and space begins to belong to something larger. Crossing it feels like stepping from a familiar home into a vast, open world. And just past this soft threshold lies a protective shell of starlight and particles. Fact 9. The heliosphere's gentle shell. Surrounding our entire solar system is a vast bubble called the heliosphere, a fragile, shimmering cocoon formed by the solar wind. Inside it, the sun's influence still lingers, creating a sanctuary that shields us from much of the galaxy's harsher radiation. Imagine it as a glowing, invisible lantern light, stretching far beyond the planets, cradling us in its warm embrace. At its outer edge lies the heliopause, the true boundary where interstellar space begins. It's here that the last whisper of the sun fades into the broader song of the Milky Way. A starship passing through would feel no jolt, no shift, only a subtle change, like stepping from one room into another, quieter one. And beyond that peaceful doorway, the journey truly becomes interstellar. Fact 10. First steps beyond the solar shore. Once we slip past the heliopause, we step into a realm untouched by the sun's familiar warmth. It's a little like leaving a sheltered harbor and drifting into the open sea. The calm changes. The space feels wider. The quiet grows deeper. Here, the particles around us no longer come from our star, but from the broader galaxy, drifting in slow, ancient currents. For the first time, a starship would be sailing not through solar space, but through true interstellar waters. There is no border sign, no sudden shift, just a gentle transition, like a lingering exhale from home, followed by the soft inhale of the galaxy itself. And in that breath, the laws of the cosmos begin to shape the journey ahead. Beyond this first step, the rules of light and time quietly take hold. Fact 11. The speed limit of light. In everyday life, speed feels simple. A car moves faster than a bicycle, a jet faster than a bird. But in the deep architecture of the universe, there is a final boundary written into space itself. Light moves at almost 300,000 kilometers per second, and nothing with mass can ever quite reach it. It's the cosmic speed limit, a gentle but absolute rule. When we imagine traveling to distant stars, we measure everything in fractions of this speed. Even at 10% of light speed, unimaginably fast by human standards, a journey to the nearest star would still take decades. But this limit isn't a punishment. It's simply part of the universe's quiet design, a rhythm we must learn to travel with. And when we move quickly enough, something strange begins to happen to time. Fact 12. Why mass resists moving fast. The faster something moves, the more it seems to resist going faster, as if the universe is gently holding it back. This resistance isn't friction or drag. It's a property of mass itself. As speed increases, the energy needed to accelerate rises steeply, stretching toward infinity as we approach light speed. It's a soft reminder that nature has boundaries, even in the vastness of space. For a starship, this means immense amounts of energy are required just to nudge its velocity a little higher. It's like trying to run through deep water. Each step becomes harder than the last. Yet within this challenge lies a quiet beauty. The idea that the universe has its own tempo, a slow and deliberate pulse guiding every journey. And at higher speeds, that pulse begins to reshape time itself. Fact 13. Time's slow dance at high velocity. As a spacecraft drifts closer to the cosmic speed limit, time begins to change its rhythm. To those aboard, everything feels normal. Seconds tick softly. Breaths rise and fall in their familiar pattern. But compared to the universe outside, their time runs just a little slower. Minutes stretch, hours lengthen, and years fold gently inward. This strange effect, called time dilation, isn't violent or dramatic. It's subtle, quiet, like a clock, taking longer pauses between its ticks. For interstellar travelers, it means they age more slowly than those who remain behind. A journey lasting decades on the ship might mean far more years have passed on distant Earth. And with this soft bending of time, space itself begins to stretch in unexpected ways. Fact 14. Relativity's soft stretching of space. Einstein's theory of relativity tells us that space and time are woven together into something fluid, something that shifts gently depending on motion and gravity. When a starship moves at a significant fraction of light speed, distances along its path begin to contract. Space seems to draw inward, shortening the journey ever so slightly from the traveler's point of view. They wouldn't feel it happening. There's no sensation of shrinking or compressing. Instead, the universe seems to cooperate quietly, smoothing the road ahead. What appears impossibly distant from Earth becomes a little closer for those in motion. It's as if the cosmos rewards their effort with a subtle easing of the path. But even with these soft gifts from relativity, the energy needed for such travel remains immense. Fact 15. Energy requirements. That whisper. Impossible to push a vessel to high fractions of light speed, the universe asks for tremendous energy, far more than anything we currently know how to produce efficiently. Accelerating even a small ship to just a fraction of light speed would require a fuel source brighter than any earthly engine. The numbers can seem overwhelming, almost dreamlike in scale. Yet this challenge is not a closed door. It's a quiet nudge, encouraging us to seek new sources of power, fusion, antimatter, and other possibilities still resting in the realm of theory. The demands of interstellar travel remind us that the universe is vast, but not hostile, difficult, but not unreachable. It simply asks for patience, creativity, and wonder. And among these potential power sources, one glows with the promise of starlight itself. Fact 16. The promise of fusion, though. Fusion is the quiet engine of the stars, a process so steady and serene from a distance that we barely notice it fuels everything we know. Inside suns, hydrogen atoms merge, releasing tremendous energy in soft, glowing waves. For interstellar travel, fusion holds a promise unlike any other: the idea of carrying a tiny star's heartbeat aboard a ship. If we could harness this reaction in a controlled, sustained way, a starship might accelerate for years, sipping fuel slowly as it glides through space. The vessel wouldn't leap forward suddenly. It would build speed gradually, like a long breath being exhaled into the cosmos. Fusion's warmth could light the path between worlds, turning the darkness into something gently welcoming. And beyond fusion's steady glow lies an even more potent possibility. Fact 17. The quiet potential of antimatter. Antimatter is one of the universe's strangest companions, a mirror version of ordinary matter, identical in weight, but opposite in charge. When antimatter meets matter, they vanish together in a burst of pure energy. It's a bright, elegant process, and if controlled, it could provide power far beyond anything fusion offers. A starship fueled by antimatter would need only tiny amounts to create enormous thrust. But producing and storing antimatter is delicate work. Even a single stray particle could cause it to react too soon. Still, the idea remains quietly enchanting. It imagines a vessel warmed by the energy of perfect balance, matter and antimatter meeting, canceling, releasing light. And for ships that don't carry fuel at all, there's another path, riding on the pressure of light itself. Fact 18. Photon, sails, and starlight winds. A photon sail is one of the simplest and most graceful ideas in interstellar travel. Picture a vast, thin sheet, lighter than paper, shimmering like a whisper, stretched out in the starlight. Photons, the tiny particles of light, have no mass, yet they carry momentum. When they strike the sail, they give it a gentle push. With enough starlight or laser light behind it, a sail could drift across the galaxy, slowly gaining speed without burning fuel. It wouldn't roar or tremble. It would accelerate as quietly as a falling feather, moved only by the softest touch imaginable. Over years, that touch becomes a steady, powerful glide. And with that gentle pressure, the dream of propulsion turns toward beams and lasers from far-reaching worlds. Fact 19. The push of distant lasers. While starlight offers a gentle nudge, lasers provide a focused, steady push, like a long, calm breath guiding a sail across the dark. In concepts such as breakthrough starshot, powerful Earth-based lasers would shine on an ultralight sail, accelerating it to a significant fraction of light speed. There's no fuel aboard, no propellant to carry, only the quiet partnership between light and a delicate sheet gliding through the void. The acceleration would begin slowly, barely noticeable, but over time the photon pressure would build until the craft moved faster than any human-made object ever has. Smooth, silent, and untouched by friction, it would slip away from home and into the deep night. And once it drifts beyond the sun's cradle, it joins a lineage of explorers already wandering the dark. Fact 20. Riding the pressure of light. The idea of riding on light feels like something from a dream, weightless, effortless, and calm. Yet the physics is remarkably gentle. Each photon that touches a sail imparts a tiny push, almost too small to imagine. But over millions and billions of these touches, a steady force builds, like a breeze forming on a still morning. For interstellar craft, this method avoids the heavy engines and fuel of traditional travel. The vessel simply spreads its luminous wings and lets the universe do the work. Slowly, it drifts faster and farther, its path guided by beams from home or by the soft glow of distant stars. And as we imagine such vessels gliding through the darkness, we remember the first real explorers who have already begun this journey. Fact 21. Voyager's long sleepward drift. Launched in 1977, the Voyager spacecraft were never meant to reach another star, yet they've traveled farther than any human-made object. For decades, they've drifted outward, past the giant planets, past the frozen edges of the solar system, and now into true interstellar space. Their speed is slow by cosmic standards, but steady, like an old traveler pacing a quiet road. Voyager carries instruments that still whisper faintly back to Earth, though their power grows weaker each year. As they drift, they measure the density of particles, the temperature of the dark, and the subtle rhythms of the interstellar medium. They are our first messengers to leave the sun's embrace, small, brave, and endlessly patient. And following their path leads us toward another artifact drifting through eternity. Fact 22. The Golden Record's cosmic whisper. Attached to each Voyager spacecraft is a small, shimmering disk, the golden record, a quiet message from Earth to whatever might someday find it. Etched into its surface are sounds of our world, the rush of wind, the rhythm of rain, greetings in many languages, and music that stretches across cultures and centuries. It is not a beacon demanding attention, but a gentle offering, like a seashell left on a distant shore. The record also carries images encoded in simple patterns, showing life on Earth, landscapes, animals, and the branching shapes of humanity's many cultures. In the silent dark between stars, this little archive drifts softly onward, keeping a tender memory of our home alive. And just ahead of Voyager's path lies another quiet traveler from Earth's early steps outward. Fact 23: Pioneer trails into the dark. Before Voyager, the Pioneer 10 and 11 missions charted the first human paths beyond the orbit of the outer planets. These probes were small, simple by today's standards, but full of purpose. They captured the first close images of Jupiter and Saturn, sending back views that widened our understanding of the solar system. Then, after their planetary encounters, they continued outward into the dark. Each Pioneer spacecraft carries a plaque, a soft, visual introduction to humanity, engraved in metal that may last longer than our species itself. The plaque shows the shape of our bodies, our place in the galaxy, and a quiet gesture of greeting. As the probes drift farther from home, their signals grow faint, but their journey continues in perfect silence. And beyond the Pioneers, a newer Voyager still watches the far frontier. Fact 24: New Horizons and the Kuiper. Calm launched in 2006. New Horizons sped past every planet in our solar system and offered the first close view of Pluto, a world once imagined only as a faint dot. As it moved through the Kuiper belt, it revealed icy worlds untouched for billions of years, drifting quietly in the sun's fading glow. These distant objects orbit slowly in an ancient dance that has changed little since the solar system's beginning. Now, New Horizons continues its long departure, studying the gentle environment of the Kuiper belt's outer edges. Its instruments listen to the soft hum of particles and measure the thin dust that drifts through this cold region. In time, like the Voyagers and Pioneers, it too will slip into interstellar space. And just beyond its path, humanity's first true interstellar artifacts wait with endless patience. Fact 25: Humanity's first interstellar artifacts. The Voyagers, Pioneers, and soon New Horizons are more than machines drifting through the quiet dark. They are our first physical footprints beyond the sun's reach. These small spacecraft, built decades ago with the technology of their time, have now become timeless travelers. They carry no crew, no passengers, only the echo of human curiosity sealed in metal and wire. Someday, long after Earth has changed in ways we cannot imagine, these probes will still be wandering. They will pass near distant stars, drifting like tiny seeds carried by a cosmic breeze. Though they may never be found, their very presence in interstellar space is a reminder that humanity once looked up, wondered, and reached outward with hopeful hands. And as they drift farther from home, they begin to fade into the deep cold. Fact 26: Why these craft will outlive us. In space, where there is no weather, no air, and almost no friction, a spacecraft can travel for millions of years with no more wear than a single grain of dust. The Voyagers and Pioneers are not immortal in the usual sense. Their instruments will fail, their signals will stop, and their power will fade. But their physical bodies, made of metal and silence, will endure. They may collide with nothing for eons. Most of space is so empty that an object could travel the length of the galaxy without striking a single grain of dust. This near-perfect stillness means that the oldest things humanity has ever created will someday become some of the oldest relics drifting through the Milky Way. And as their systems cool to darkness, their mission gently changes. Fact 27. The slow cooling of far-flung probes. Every spacecraft carries a limited source of heat, small nuclear batteries, or electronic warmth that keeps its instruments alive. As these probes drift into deep space, their power supplies slowly decay. One by one, their instruments fall silent as the internal temperatures sink toward the cold of the interstellar night. Eventually, even the last dim warmth will fade. But this cooling is not a failure. It is simply a final step in their long voyage. Once their systems grow quiet, the probes continue as peaceful, unpowered travelers, drifting without effort, without need, through the galaxy's hushed expanse. They become more like cosmic fossils, preserved by the stillness of space. And in their silence, they carry messages meant for a distant future. Fact 28. Messages to an unknown future. Every interstellar probe carries something more than instruments and machinery. It carries a quiet hope stitched into its design. The golden record on Voyager, the plaques on the Pioneer probes, even the subtle markings on New Horizons speak to whoever or whatever might find them long after we are gone. These messages are not loud declarations, but gentle introductions. We were here. We wondered. We cared. They show the layout of our solar system, the outline of our bodies, the pulse of our languages, and the music that moved us. They are time capsules drifting through eternity, waiting for a moment of discovery that may never come. Yet the beauty lies in the offering itself, a gift we send into the dark, asking nothing in return. And as these messages wander, the probes themselves continue their lonely watch. Fact 29. The loneliness of a silent explorer. A spacecraft in interstellar space experiences a solitude deeper than anything on Earth. There is no breeze, no sound, no sky, only the slow drift of particles and the faint pull of distant stars. The silence is absolute, so complete that a ship's own electronics once hummed like a heartbeat against it, until those too faded away. As the years pass, the link with Earth weakens. Signals that once arrived in minutes stretch to hours, then fade beyond detection entirely. But the probe continues onward, bound by no gravity, guided by no command, sailing gently through the galaxy like a bottle released into an endless ocean. In that loneliness lies a quiet dignity, a traveler that keeps going, even when no one can hear it anymore. And in the vast patience of this journey, time itself becomes the companion. Fact 30. The endless patience of deep space. Travel. In interstellar space, movement is measured not in days or months, but in lifetimes. A probe may drift for tens of thousands of years before nearing another star, its path unchanged by anything but the faintest whispers of gravity. This patience is not forced. It is simply the natural pace of the cosmos, where nothing is rushed and everything unfolds in its own slow rhythm. To a deep space traveler, time stretches out like a calm horizon. There is no urgency, no schedule, only the gentle continuation of a journey that began long ago. In this vast quiet, even the smallest motion carries meaning, a steady glide, a silent rotation, a drifting turn toward the unknown. And as humanity dreams of joining these patient explorers, we begin to imagine the vessels that might someday carry us through the dark. Fact 31. The starship as a traveling home. When we imagine a starship built for interstellar travel, we're not picturing a simple vehicle. We're imagining a moving world, a quiet sanctuary drifting through the dark. Such a ship would need to be more than metal and engines. It would need to be a home, a place where people sleep, dream, grow, and live while the stars shift slowly outside. Inside, the hum of life support systems might feel like a soft heartbeat. Lights would mimic sunrise and sunset, helping minds stay anchored to the gentle rhythm of time. Food would be grown in small gardens, air would be recycled and refreshed, and water would move through closed loops like a peaceful river. A starship would be a tiny echo of Earth, carrying comfort into the unknown. And for journeys lasting generations, that home would become a world of its own. Fact 32. Generational worlds on the move. A generational starship is a vessel so vast and self-sustaining that entire lifetimes unfold within its walls. The people who depart from Earth would not be the ones who arrive at a distant star. Children would be born in the quiet corridors, grow beneath artificial skies, and learn to navigate a life where the universe outside is always present, yet always out of reach. Such a society would create its own traditions, its own celebrations, its own gentle rhythms. Stories of Earth might feel like legends, passed down like lullabies. The ship itself would feel like a wandering village, a place where community grows in the stillness between suns. To its inhabitants, the long journey wouldn't feel like waiting. It would feel like simply living. And for those who dream of seeing another star with their own eyes, a different path is imagined. Fact 33. The dream of cryogenic journeys. Cryogenic travel imagines a voyage where travelers sleep through the long crossing, their bodies cooled to a deep, safe slumber. Instead of generations living aboard, the same crew who begins the journey wakes centuries later beneath the light of another sun. The sleep would be dreamless, gentle, like pausing life and restarting it far from home. In this vision, the ship glides silently while its passengers rest. Systems monitor their vital signs, keep temperature steady, and watch over them as if guarding a room full of softly sleeping friends. When the journey ends, the warmth returns slowly, breath by breath, heartbeat by heartbeat, until the travelers awaken to a new chapter of human exploration. And beyond cryogenic sleep lies another kind of slumber, one that slows life to a delicate, suspended stillness. Fact 34. Suspended animation soft promise. Suspended animation imagines the body placed into a state so quiet that its processes slow to a near stillness. Heartbeats become faint, breaths grow shallow, and metabolism drifts like a candle flame turned low. Unlike full cryogenic freezing, this method keeps travelers alive but deeply resting, preserved in a tranquil pause that could last months or years. The ship would become a kind of floating dormitory, each passenger resting in a capsule that monitors every subtle signal of their body. Machines would adjust temperature, deliver nutrients, and keep the cells gently balanced. In this peaceful dormancy, the long stretches between stars would pass unnoticed, like a single extended exhale. When the time comes to wake, the transition would be slow and warm, easing travelers back into the world. And for those who stay awake, life continues to unfold aboard the drifting vessel. Fact 35. The problem of life support. Over ages. Keeping people alive for decades, or even centuries, isn't just about air and water. It's about creating an entire environment where balance becomes the most important companion. Oxygen must be renewed, carbon dioxide filtered, food grown or recycled, and waste transformed into something useful. Every system must run quietly, reliably, and with the softness of a closed, self-sustaining circle. Over long periods, even small imbalances could disrupt the delicate harmony. Plants must thrive under artificial light. Microbes must remain under control, and the humans aboard must remain physically and emotionally well. A starship built for such durations becomes a kind of living ecosystem where each part depends gracefully on every other. Its success lies not in strength, but in stability. And at the heart of this floating ecosystem bloom the gardens that keep life colorful and calm. Fact 36. Living ecosystems in black sky transit. A starship designed for long journeys would likely carry its own miniature forests, gardens, and water systems. These living spaces would offer more than nourishment. They would bring beauty and comfort. Green leaves swaying beneath soft lamplight, the quiet trickle of recycled water, the gentle scent of growing herbs. All of it helps anchor the human spirit during the endless night outside. Plants purify the air, balance humidity, and return oxygen to the ship in a slow, breathing rhythm. Small ponds or algae tanks might shimmer like tiny lakes, reflecting artificial skies. The ecosystem would become a refuge, a reminder of the warmth of Earth, even as the starship glides through cold, star-dusted emptiness. And as the vessel drifts forward, its engines whisper with a steady, persistent patience. Fact 37. The beauty of slow, steady acceleration. In the vacuum of space, speed isn't about sudden bursts. It's about patience. A starship doesn't need to leap forward like a rocket leaving Earth. Once free of gravity's embrace, it can rely on quiet, continuous acceleration. Even the softest push, applied for months or years, can build to extraordinary velocities. It's like feeling a constant, delicate breeze guiding you across an infinite sea. Travelers aboard such a ship wouldn't feel the acceleration after the first moments. Life would settle into a gentle rhythm, with gravity provided by rotation or a slight, steady thrust. Outside, the stars would gradually shift, their patterns stretching into long, delicate arcs as the ship gathered speed. It's a journey that begins softly, grows steadily, and carries its travelers deeper into the night. And at the heart of this steady motion lies the warmth of powerful engines. Fact 38. Nuclear propulsion's warm heart. Nuclear propulsion imagines using the quiet strength of atomic reactions to push a ship between the stars. Unlike chemical rockets, which burn brightly and briefly, nuclear engines can glow with steady power for long stretches of time. They might work by heating propellant to incredibly high temperatures, or by directing bursts of particles outward in controlled, glowing streams. Inside the ship, travelers wouldn't hear the engines work. It would be a distant hum, softened by layers of shielding, as calm as a heartbeat behind a thick wall. The warmth from the reactor would provide electricity, heat, and life support energy for years. In a way, a nuclear-powered starship is a tiny sun-carrying vessel, borrowing the quiet strength of the universe's most abundant processes. And further along that path lies an even more star-like engine, fusion. Fact 39. Fusion drives and quiet suns in miniature. A fusion drive is a promise written in light, a miniature star, carefully tamed, glowing at the heart of a spacecraft. Using light elements like hydrogen or deuterium, the engine would fuse atoms and release tremendous amounts of energy. Unlike fission, fusion is clean, efficient, and stable, mirroring the same gentle reactions that make stars shine across the galaxy. A fusion-powered starship would accelerate for long periods, sipping tiny amounts of fuel compared to the immense energy it produces. Its exhaust would glow faintly, a soft ribbon of light in the darkness. To those on board, the fusion engine would be a warm companion, quietly powering lights, air, and dreams as the ship glides through the interstellar night. And beyond fusion's warm glow lies another technique, one that uses the galaxy's own winds to sail the stars. Fact 40. Magnetic sails. Catching ghostly winds. A magnetic sail, or magsail, is a quiet, elegant idea. Instead of capturing starlight with a thin sheet, it spreads out an invisible magnetic field that pushes against charged particles drifting through space. These particles, though incredibly sparse, flow steadily from stars and the galaxy itself. As they strike the magnetic field, they impart a soft, continuous push, like wind filling a sail no one can see. A magsail could help a ship slow down as it approaches another star, or even accelerate as it leaves the solar system. There is no fuel to burn, no glowing engine to maintain, only the natural currents of the cosmos guiding the ship forward. It's interstellar travel, powered by the universe's own breath. And beyond these gentle winds, imagination reaches for ideas that bend space itself. Fact 41. The idea of the Alcubierre bubble. The Alcubierre drive is a theoretical concept that sits at the edge of physics, somewhere between dreaming and mathematics. It imagines a spacecraft not moving through space, but carried within a bubble of distorted space-time. Space in front of the ship would gently contract, while space behind it would softly expand, letting the vessel drift forward without ever breaking the speed of light. Inside the bubble, the travelers would feel nothing unusual. No acceleration, no pressure, just a quiet stillness. The ship wouldn't be moving faster than light relative to the space-time around it. Instead, space-time itself would be doing the work. It's a poetic idea, the universe opening a path by folding itself into a gentler shape. And at the heart of this concept lies the notion of space as something that can be squeezed and stretched. Fact 42. Warp space as gentle compression. If space can stretch, as we know it does when the universe expands, then in theory, it can also compress. Warp concepts imagine shaping space-time like soft clay, forming a pocket where distances shrink ahead of the ship and lengthen behind it. This gentle compression isn't a violent tearing or ripping. It's more like creating a small ripple on the surface of a still pond. For travelers inside, the journey would feel serene. They would sit within a calm bubble while the space around them shifts and flows. The stars ahead would draw closer, not because the ship speeds through the void, but because the void itself reshapes its contours. While such technology remains far beyond our reach, the dream itself adds a quiet beauty to our understanding of space. And just beyond this dream, the universe hints at even stranger paths through the dark. Fact 43. Why negative energy is so elusive. Many warp and wormhole ideas require something the universe rarely provides: negative energy. Not negative in a harmful sense, but negative in a mathematical one. A peculiar state where energy bends space-time in the opposite direction of ordinary matter. In theory, it could stabilize tunnels or allow bubbles of warped space to form. But in practice, it's faint, fleeting, and incredibly difficult to create. Quantum physics hints at tiny pockets of negative energy that appear for the briefest moments, like ripples flickering on a silent lake. These effects are real, but far too delicate to harness with today's understanding. They remind us that the universe has layers we barely comprehend, and that some of its most beautiful possibilities remain hidden, waiting for deeper insight. And beyond negative energy lies another path through space-time, one imagined as a folded shortcut. Fact 44. Wormholes as folded pathways. A wormhole is often described as a tunnel through space, but it's gentler to imagine it as a fold in a vast cosmic blanket. Instead of traveling across the full distance between 2 points, a wormhole brings them together, letting a traveler step from one region of space to another almost instantly. In storytelling, wormholes open like shimmering doorways. In theory, they require precise balances of energy and stability. If one were stable enough for passage, entering it wouldn't feel like falling. It might feel more like stepping into a dim corridor, surrounded by warped geometry that bends light into soft, swirling patterns. Exiting on the other side could reveal a star system millions of years away, a quiet promise of connection in an otherwise expansive galaxy. Yet even in thought experiments, wormholes are fragile things. Fact 45. The fragility of hypothetical gates. A stable wormhole would be a delicate creation, held open by forces still not fully understood. The slightest imbalance of energy could cause it to collapse, closing the path as quickly as it opened. Some theories suggest that wormholes might flicker into existence naturally, but vanish again almost instantly, appearing like fireflies in the dark fabric of space-time. Even if we discovered one, passing through it might be impossible without reinforcement. Their walls, if they could be called walls at all, would shift with the motion of matter and the pressure of energy. Like a soap bubble stretched across the cosmos, a wormhole would be beautiful but transient, a portal that exists more in theory than in practice. And just beyond these fragile gateways, physics offers even stranger whispers about the nature of particles and possibility. Fact 46. Quantum tunneling dreams. Quantum tunneling is one of the gentlest yet most surprising behaviors in nature. In the tiny world of particles, boundaries are not as solid as they seem. A particle may find itself on the other side of a barrier without ever breaking it, slipping through in a way that defies our everyday sense of motion. It's as if the universe allows small things to wander through walls when the conditions are just right. For interstellar travel, some dreamers imagine this effect on a grander scale, not as people tunneling through obstacles, but as hints that space itself might contain hidden pathways. These ideas remain soft speculation, far from practical, yet they remind us that the universe is more flexible and mysterious than it looks from afar. And flowing from this mystery is the idea of matter that behaves unlike anything we know. Fact 47. The power of exotic matter. Exotic matter is a catch-all name for substances that don't follow the usual rules. Matter with unusual pressures, strange charges, or behaviors that bend space-time in uncommon ways. It's a theoretical ingredient often invoked for warp drives, wormholes, and other speculative technologies. But in real physics, exotic matter is elusive, delicate, and poorly understood. Some forms might have densities far beyond anything found on Earth. Others could interact with gravity in ways that feel almost dreamlike, pushing instead of pulling, or curving space-time in unfamiliar patterns. Though we have not discovered stable examples of exotic matter, the possibility encourages scientists to keep asking gentle questions about what the universe truly allows. And if exotic matter exists, then controlling space-time becomes an even greater challenge. Fact 48. The challenge of stabilizing space-time. Shaping space-time, compressing it, stretching it, or folding it, requires extraordinary precision. Even small distortions involve energies far beyond our current technologies. Stabilizing these distortions would mean managing gravitational forces with exquisite delicacy, ensuring that the bubble or tunnel remains smooth, steady, and safe for whatever traveling vessel lies within. Imagine trying to hold a soap bubble steady in a strong wind. Space-time behaves with similar sensitivity. A slight imbalance could cause the structure to collapse, flatten, or twist unpredictably. Yet the idea of stabilizing space-time remains a beautiful challenge. It invites us to imagine technologies far in the future, crafted with patience and understanding, born from a deeper relationship with the cosmos. And beyond this delicate shaping lies the dream of traveling faster than light, not through space, but alongside its echoes. Fact 49. Imagining faster than light echoes. Even though physics tells us we cannot outrun light, imagination often wonders what it might feel like if we could move alongside its echoes. In science fiction, faster-than-light travel appears as luminous streaks, sudden jumps, or drifting corridors of shimmering distortion. But in a softer, more contemplative sense, it can be pictured as slipping into a quieter rhythm of the universe, one where distances fold gently and stars draw close like old friends. If such travel were ever possible, it might not feel fast at all. It might feel serene, as though the universe had simply decided to shorten the space between 2 points. Travelers would glide through this softened reality, watching constellations rearrange themselves with graceful ease. And even though such journeys remain imaginary for now, they remind us that possibilities often begin as dreams. Fact 50. Why even impossible ideas inspire us. Some concepts in interstellar travel may never leave the realm of theory. Warp bubbles, wormholes, negative energy, exotic matter. But these ideas still serve an important role. They remind us that curiosity has no limits, even when physics draws boundary lines. Thinking about the impossible helps us understand the possible more clearly. It pushes us to refine our knowledge, to invent new tools, and to look at the universe with fresh, patient eyes. Even if humanity never walks through a wormhole or rides a wave of compressed space-time, the act of exploring these ideas lights a quiet fire in the mind. It encourages the next generation of thinkers to keep asking questions, soft, persistent questions that gently reshape our understanding of the cosmos. And as these questions deepen, we turn back to the ships and the people who might someday make the journey. Fact 51. Artificial daylight for wandering minds. Life aboard an interstellar vessel would mean living far from any natural sunrise. To keep minds calm and bodies healthy, the ship would create its own cycles of day and night. Lights would warm slowly in the morning, glowing with soft golden hues that mimic a gentle dawn. Over the course of hours, they would brighten into a comfortable midday before fading again into a cool, quiet evening. This artificial rhythm would steady the travelers' internal clocks, comforting them with familiar patterns even as stars drift silently outside. In the soft glow of these manufactured mornings, people would stretch, breathe, and begin their days as though living beneath a distant sky. It's one of the many ways a ship becomes a home, carrying pieces of Earth's warmth into the dark. And within this carefully crafted world, Even the ship itself develops a voice, a quiet hum that fills its drifting halls. Fact 52. The sound of a ship in deep drift. In the quiet of interstellar space, a starship has no roar, no rush of wind, no echoing engine blasts. Instead, the sounds inside are soft and intimate. A low hum from life support systems, the gentle whir of circulation fans, the faint pulse of water moving through recycled pipes. These noises blend into a calming background, like the ship itself is breathing slowly beside its passengers. Over time, these soft sounds become part of daily life. Travelers learn to sleep to the steady heartbeat of the vessel, to think clearly in its subtle vibrations, to feel comforted by the quiet consistency. In a universe stripped of familiar noises, the ship's soft mechanical lullaby becomes the soundtrack of the journey. And within that peaceful soundscape, travelers often seek places of living green. Fact 53. Growing gardens between the stars. On a long interstellar voyage, gardens are more than a source of food. They are sanctuaries. Rows of plants sway gently under artificial lights. Leaves soften the sterile edges of the ship, and the smell of earth reminds travelers of the world they left behind. In the midst of cold metal walls and endless dark outside, these gardens offer warmth, color, and emotional grounding. People might visit them to meditate, to breathe deeply, or simply to feel the presence of life around them. The air here is fresh and humid, a gentle contrast to the crisp interior of the craft. Watching new sprouts emerge or touching a leaf warmed by grow lights creates a sense of continuity, a reminder that growth continues even when the stars are the only sky. And in this living haven, the mind finds rest from the long, quiet nights of deep space. Fact 54. The psychology of endless night. Interstellar travel means spending years, perhaps decades, enclosed within a vessel where the universe outside is always dark. This endless night can be both soothing and challenging. While some find comfort in the consistency, the calm stillness, the lack of sudden change, others may long for the familiar cycle of day and sunlight. To keep minds balanced, starships would cultivate routines, shared activities, and gentle lights that mimic the warmth of home. Travelers might gather in communal areas beneath artificial skylights, or follow daily rituals that create structure and stability. Conversations, storytelling, communal meals, all become anchors in a landscape without dawn. Emotional health becomes as important as fuel and oxygen, for a peaceful mind keeps the journey steady. And beyond this psychological landscape lies the deeper art of letting go, trusting the voyage, and embracing rest. Fact 55. Hibernation and the art of letting go. For some interstellar journeys, travelers might enter periods of controlled hibernation, not full suspended animation, but a gentle slowing of the body's rhythms. Heartbeats ease into a soft cadence. Breathing becomes shallow and peaceful, and brain activity slips into deep rest. In this state, the long years of travel pass quietly, like a dream stretched across centuries. The ship would watch over each sleeper tenderly, adjusting temperature, nutrients, and oxygen with steady precision. Waking would be gradual, as though rising from the deepest, most restful slumber. Hibernation teaches a kind of trust, a willingness to surrender to time, to let go of waking hours, and to accept the universe's slow unfolding. And for those who remain awake, life continues to bloom in unexpected ways. Fact 56. Families born far from any sun. On a generational vessel, New families might be born far from the light of any natural star. Their first memories would be of softly lit corridors, gentle artificial mornings, and gardens glowing with quiet life. Stories of Earth would reach them like distant myths, tales of oceans they have never touched, skies they have never seen, and seasons that unfold in rhythms unknown aboard the ship. These children would grow up seeing the universe as an endless home, not a distant frontier. They'd develop their own games, traditions, and comfort in the hum of the ship's heartbeat. Their parents might teach them constellations through screens or point out distant stars through viewing ports, letting them imagine the worlds that lie ahead. And as generations pass, a unique culture begins to form, one shaped by quiet travel and shared purpose. Fact 57. The culture of a starfaring society. Life aboard an interstellar vessel would naturally give rise to its own customs. Celebrations might mark each passing year of the journey, or each time the ship completes a quiet rotation around its axis. Travelers might honor the founding day when their ancestors first left Earth, or gather in gardens to share stories beneath soft artificial twilight. Art, music, and rituals would evolve to suit the gentle pace of life in the deep dark. A starfaring culture would value patience, cooperation, and emotional steadiness. Resources would be shared carefully, and every task, from tending algae pools to repairing hull sensors, might carry a sense of communal meaning. Over time, the ship itself becomes part of their identity, a floating village bound by starlight. And in moments of joy or reflection, these travelers might celebrate quietly in the vastness of the void. Fact 58. Quiet celebrations in the void. Even in the deep dark between stars, people find reasons to celebrate. Birthdays, anniversaries, shared milestones, and small victories become gentle markers along the long journey. A celebration aboard a starship wouldn't be loud or extravagant. It would be soft, communal, and heartfelt. Travelers might gather under warm lights, share food grown in the ship's gardens, or sing songs that echo softly through metal corridors. Some holidays might be unique to ship life: the day of launch, the day of crossing the heliopause, or the day the vessel passes its halfway point to a distant star. In these quiet moments of togetherness, laughter becomes a soothing balm, reminding everyone that even in the farthest reaches of space, human connection shines like a lantern in the dark. And when the celebrations fade, the stars outside still wait patiently to be seen. Fact 59. Stars seen from a moving world. From a starship gliding through interstellar space, the stars would appear sharper, steadier, and more numerous than they ever do from Earth. Without atmosphere to blur or twinkle them, each star becomes a perfect point of light, shining with quiet clarity. Over years of travel, the patterns of constellations would shift subtly as the ship moves deeper into the galaxy. Familiar shapes would stretch, new patterns would form, and travelers might name fresh constellations after their own stories. Watching the stars becomes a nightly ritual, a grounding presence in the long dark. Some travelers might stand at observation windows for hours, tracing soft arcs of motion, imagining the worlds hidden beyond each distant light. In this starlit silence, the vastness feels less overwhelming and more like a gentle companion. And as time stretches onward, the generations aboard the ship drift with it. Fact 60. The passage of generations in the dark. On a voyage lasting centuries, generations unfold like chapters of a slow, beautiful book. The earliest crew members grow older, sharing their knowledge with children who were born on the ship. Those children eventually become adults and teach yet another generation. Each group adds new layers to the ship's culture, new art, new customs, new dreams shaped by life in the endless night. The ship itself might feel alive with memory, its walls holding echoes of countless footsteps and soft voices. Older travelers may sit in gardens, telling stories of Earth to younger listeners who can only imagine oceans and open skies. And as the ship glides onward, each generation contributes to its quiet legacy, moving together toward a future none of them will see alone. And just beyond this evolving community lies the environment of the interstellar medium itself, waiting with mysteries of its own. Fact 61. Cosmic rays in the quiet black. The interstellar medium may feel peaceful, but it carries a faint rain of energetic particles known as cosmic rays. These particles drift through the galaxy at incredible speeds, born from ancient supernovae and other powerful cosmic events. Unlike the soft glow of starlight, cosmic rays are invisible and silent, passing through vast distances without slowing. For a starship, they are like occasional, unseen visitors in the dark. To protect travelers, thick shielding or magnetic barriers would soften their impact, turning the cosmic storm into something manageable and safe. Inside the ship, life would continue in calm routine, while outside, these particles glide past like tiny messengers from distant stars. Their presence is a reminder that even in stillness, the galaxy hums with quiet energy, and drifting alongside these rays are the smallest grains traveling the longest roads. Fact 62. Dust grains, traveling near light speed. Most of space is empty, but tiny grains of dust still wander through it. Remnants of ancient stars, shattered planets, and drifting clouds. In interstellar space, these grains can move incredibly fast, sometimes at a significant fraction of the speed of light. Though each one is no bigger than a speck of sand, their high speed gives them surprising energy. A starship must protect itself from these tiny travelers. A single grain striking a vessel at such speeds could cause damage, so the ship's hull might include layered shielding or a magnetic field that deflects charged particles. Yet even with this protection, the thought of these grains, tiny and persistent, drifting for millions of years through the dark, feels strangely poetic. And beyond these specks lie the vast magnetic fields that weave quietly through the galaxy. Fact 63. The magnetic fields that drift across space. The Milky Way is threaded with enormous magnetic fields, stretching between stars like invisible strands of silk. They are faint, delicate, and constantly shifting, shaping the movement of charged particles and guiding cosmic rays along elegant arcs. These fields do not roar or snap. They whisper, moving slowly with the rotation of the galaxy. A starship traveling through interstellar space would pass through these fields without sensation, though its instruments could detect their subtle strength. The ship's own magnetic systems might interact gently with them, creating tiny perturbations that drift harmlessly into the void. These fields remind us that the galaxy is not empty, but interconnected, woven together by forces we cannot see. And within this woven fabric lies the need for thoughtful protection from the silent hazards of the deep dark. Fact 64. Why shielding matters. Most in the void. In the deep calm between stars, a starship appears to float through perfect stillness. But that stillness is sprinkled with high-energy particles, drifting dust, and faint cosmic radiation. Shielding becomes the vessel's quiet guardian, absorbing or deflecting what the human body cannot sense. There is no sound when radiation touches the hull, no spark or flash, only a soft interaction between matter and energy in the cold. Layers of metal, water, or magnetic fields work together like nested blankets, each capturing a different kind of particle. Inside, travelers move peacefully through their routines, unaware of the subtle protection surrounding them. This shielding makes the long journey possible, turning a harsh environment into a gentle passageway. And beyond the need for protection lies the strange, near-perfect cold of the interstellar night. Fact 65. The temperature of almost nothing. Interstellar space has no true temperature in the way we experience it, because there is almost nothing there to hold heat. But the few particles drifting in the void settle into a chill only a few degrees above absolute zero. It is a cold so deep and ancient that it feels woven into the very structure of the cosmos, a remnant whisper from the universe's earliest days. A starship moving through this realm remains warm only because of its own systems. Inside, gentle heaters, lights, and human activity keep the vessel comfortable. If all power were lost, the ship would gradually surrender its warmth to the vacuum, cooling with slow, quiet inevitability. This endless cold is not threatening. It is simply the natural temperature of almost nothing. And resting upon this cold backdrop is a faint glow, a memory from the birth of everything. Fact 66. The background. Glow of the universe. Every corner of the cosmos is touched by a soft, ancient light known as the cosmic microwave background. It is the afterglow of the Big Bang, a gentle, uniform radiation that fills space like a dim, everlasting whisper. Though invisible to the eye, sensitive instruments reveal it as a smooth field of warmth, only a few degrees above absolute zero. A starship, drifting through interstellar space, sails through this glow constantly, passing through photons that have traveled for nearly 14 billion years. To the travelers on board, nothing feels different. The background radiation is too faint to be sensed, but knowing it exists adds a quiet comfort, a reminder that even the emptiest parts of the universe still carry echoes of creation. And woven within this ancient glow are the clouds and veils that shape the galaxy's quiet beauty. Fact 67. Interstellar clouds as gentle veils. Interstellar clouds are vast gatherings of gas and dust, spread so thin that a single cubic meter might contain only a handful of particles. Yet across light years, these particles form soft, misty structures that shape the Milky Way's quiet tapestry. From afar, they appear as faint smudges or glowing patches against the darkness. Up close, they are nearly invisible, more like a suggestion than a boundary. A starship passing through such a cloud would feel nothing. No turbulence, no thickening of air, only a subtle shift in the patterns of starlight. Sensors might detect slight changes in density or temperature, revealing the cloud's delicate presence. These clouds are the galaxy's gentle veils, drifting slowly across time. And deeper within them lie regions touched by the echoes of ancient stellar winds. Fact 68. The whisper of distant supernovae. When a star ends its life in a supernova, it sends shock waves and particles sweeping into the surrounding space. Over tens of thousands of years, these effects fade into gentle whispers, but they continue to travel across light years. The interstellar medium is shaped by these old echoes, traces of immense energy softened by distance and time. a starship might detect slightly elevated levels of certain elements, or a faint change in magnetic patterns, tiny clues that a supernova once bloomed far away. These remnants enrich the galaxy, seeding it with the heavy elements needed for planets, life, and future stars. In this way, each explosion becomes a quiet benefactor, gifting the cosmos with new possibilities. And where these elements gather in greater density, something even more beautiful begins to form. Fact 69. The edges of nebulae like painted mist. Nebulae are among the most graceful structures in the galaxy. Enormous clouds of gas and dust illuminated by nearby stars. Their edges often glow with soft, colorful light. Gentle reds from hydrogen, cool blues from scattered starlight, and faint golds from warm dust. Though these colors are invisible to the naked eye in real-time travel, enhanced instruments would reveal them as drifting celestial paintings. A starship approaching a nebula would watch its edges appear gradually, like watercolors spreading across dark paper. The boundaries are not sharp. They fade slowly, becoming denser as the ship glides inward. Within these glowing regions, the ingredients for new suns and planets quietly gather. And deeper inside these clouds, stars themselves are born in darkness and silence. Fact 70. Molecular clouds as cradles of new suns. Deep within the densest parts of nebulae lie molecular clouds, cold, dark regions where gas gathers thickly enough to birth new stars. These clouds are vast, stretching for dozens or even hundreds of light years. Yet inside them, the atmosphere is serene. Temperatures drop to only a few degrees above absolute zero, and light dims to a soft twilight, filtered by layers of drifting dust. Within these hidden pockets, gravity slowly gathers the gas into tighter knots. Over millions of years, these knots grow warmer and denser until they ignite, forming newborn stars. For a starship passing nearby, the cloud would appear as a great, dark silhouette against brighter regions of the galaxy, a silent nursery where the next generation of suns slowly awakens. And as a ship leaves these cradles behind, it begins to sense the pull of another distant star. Fact 71. The first light of a distant sun. After traveling through the deep black for decades or centuries, the moment a new sun becomes visible would be profoundly moving. At first, it might appear as nothing more than a slightly brighter star among millions. But as the vessel drifts closer, that point of light grows steadier, warmer, more familiar, a promise of arrival after an age of travel. Sensors would detect its energy long before the eye sees detail. The warmth of its photons, the spectrum of its glow, the faint imprint of its winds. This distant sun would shine with its own unique color, shaped by its temperature and age, perhaps a cool orange, a soft red, or a bright white gold. For the travelers, it would feel like spotting a lighthouse on the far horizon of an infinite sea. And once the target star is found, the next great challenge awaits: slowing the journey. Fact 72. Slowing down after centuries of motion. Reaching another star is only half the journey. Slowing to meet it is just as important. A vessel traveling at a significant fraction of light speed cannot simply stop. It must apply steady, gentle braking over years, even decades. Magnetic sails might unfurl again, catching the charged particles of the new star's wind. Engines might reverse their thrust, whispering softly as they ease the ship into the system. Inside, life would continue peacefully as always. Travelers might not even notice the deceleration beyond subtle changes in the artificial gravity or the shifting starfield outside. Bit by bit, the ship's speed drops from incredible to manageable, and the distant sun grows larger and more detailed. And as the vessel slows, it begins to hear the soft breath of the new star's heliosphere, inviting it inward. Fact 73. Reading the winds of another heliosphere. Every star creates its own heliosphere, a great bubble of charged particles flowing outward like a steady exhale. As a starship drifts into the domain of a new sun, its instruments begin to sense these winds long before the travelers see planets or rings or moons. The pressure of particles rises gently, the magnetic field shifts in delicate patterns, and the environment becomes subtly warmer and more alive. Crossing the boundary of a new heliosphere is like stepping onto the outskirts of an unexplored shore. The ship moves from the silent calm of deep interstellar space into a region shaped by the star's breath. Here, radiation levels change, dust flows differently, and the fabric of space feels ever so slightly more familiar, illuminated by a fresh source of light. And once the ship settles into this new domain, the work of mapping its hidden treasures begins. Fact 74. Mapping unknown. Worlds from afar before a starship approaches any planet directly. It must study the system from a safe distance. Telescopes extend like delicate instruments of curiosity, measuring the color of planets, the shimmer of atmospheres, and the faint shadows cast by orbiting moons. Slow scans reveal temperature gradients, chemical signatures, and the presence of water or clouds. Even from millions of kilometers away, a planet begins to tell its story. Icy worlds glow with soft blue and white hues. Gas giants swirl with gentle bands. Rocky planets reflect starlight in muted tones. Mapping from afar is like reading a poem written in starlight, each line offering hints of what awaits. And as the starship drifts closer, the first glimmers of a new dawn begin to form. Fact 75. The colors of an alien dawn. On a planet orbiting a distant star, sunrise may look nothing like the warm golds and soft pinks of Earth. The colors depend on the star's light and the chemistry of the atmosphere. A red dwarf's dawn might rise in deep crimson, slowly shifting to lavender. A bright blue-white star might cast mornings in icy blue, with razor-sharp shadows stretching across the land. As light filters through alien air, it scatters and softens, painting the sky in hues unknown to human eyes. Travelers standing on a new world would watch these colors unfold with awe, a living canvas created by physics and chance. The first sunrise after centuries of travel would feel like a blessing, a gentle welcome from a world untouched by human footsteps. And beneath that glowing horizon lie secrets carved in ice, rock, and ancient starlight. Fact 76. What ice and rock reveal about a system. When travelers reach a new star, the first clues about its history often lie in its smallest bodies: the icy comets, rocky asteroids, and scattered debris that orbit in quiet belts. These objects are ancient, unchanged for billions of years, and they preserve the earliest materials of their system. By studying their shapes, compositions, and orbits, explorers can read a cosmic archive written in stone and frost. Some rocks may contain traces of complex molecules, while others hold patterns that reveal how the system formed and evolved. Ice can show the fingerprints of the star's light, how brightly it once shone, how warm it has become, and how time has sculpted its worlds. Each fragment is a quiet storyteller, offering whispers from an age before planets even formed. And once these ancient pieces are understood, attention turns to the air of the worlds themselves. Fact 77. The chemistry of new atmospheres. An atmosphere is a planet's signature, a delicate blend of gases shaped by geology, life, and the light of the star it orbits. When a starship approaches a new world, its sensors begin reading that signature long before any landing attempt. They detect the faint fingerprints of elements: oxygen, methane, nitrogen, carbon dioxide, or exotic gases unfamiliar on Earth. These chemical clues reveal a planet's personality. A world rich in oxygen might shimmer with potential life, while a methane-heavy atmosphere might glow hazy and orange. Some atmospheres could sparkle with icy particles, scattering light like drifting snow. To travelers, the knowledge of what they will breathe, or what they must avoid, becomes a gentle doorway into understanding the world below. And beneath that sky, the planet's magnetic soul begins to whisper its presence. Fact 78. The magnetic murmurs of a foreign star. Every star has a magnetic field, and many planets do too. These fields twist and ripple through space, guiding charged particles and shaping the behavior of solar winds. When a ship enters a new system, its instruments detect these magnetic murmurs as subtle variations, like faint music playing through the vastness. A planet with a strong magnetic field might glow with auroras, shimmering curtains of light dancing around its poles. The colors could be strange and beautiful, influenced by gases unfamiliar to Earth's sky. For travelers, sensing these magnetic signatures is like tuning into the heartbeat of an unknown world. They reveal rotation rates, interior structures, and the protective shields that may guard the surface from radiation. And drawn by these clues, explorers soon turn their eyes to the tides and motions of worlds they have never seen before. Fact 79. Tides on planets. We've never seen before. Tides are not unique to Earth. They are a universal conversation between gravity and water, rock, or even air. On distant worlds, tides might swell and fall under the pull of unfamiliar moons, or the steady tug of a nearby star. Some worlds may have tides far stronger than ours, lifting oceans in slow, towering waves. Others might show only the faintest ripple, barely noticeable except in careful measurements. The rhythm of these tides tells explorers about a planet's mass, its moon's distance, and the dance of gravitational forces shaping its days. On worlds with multiple moons, tides might overlap in fascinating patterns, creating rare harmonies of motion. Observing these gentle rises and falls offers a glimpse into the quiet mechanics of an alien system. And once those rhythms are understood, the moment comes to finally set foot on a new shore. Fact 80. Landing on shores. Beyond history. Touching down on a planet beyond our solar system would be one of the calmest yet most profound moments in human exploration. A landing craft would drift through the atmosphere like a falling feather, guided by sensors reading winds, temperatures, and chemical traces. Inside, travelers would feel soft vibrations as the vessel descends, each moment drawing them closer to a place no one has ever touched. The surface might welcome them with muted colors, pale sands beneath an unfamiliar sky, rocky plains glowing in foreign starlight, or oceans reflecting hues unseen on Earth. Every sound would be new: the whisper of alien breezes, the hush of distant waves, the soft crunch of ground beneath their boots. In that stillness, the enormity of the journey would settle gently into their hearts. And when night falls on such a world, it brings its own kind of wonder. Fact 81. The first night on an interstellar planet. Night on an alien world unfolds with a beauty both strange and deeply comforting. Without Earth's familiar moon, The sky may darken into a velvet shade touched by the faint glow of distant nebulae. Or perhaps several moons rise at once, painting the landscape with overlapping soft lights. The stars seen from this new vantage point arrange themselves in unfamiliar constellations, patterns that have never been given names. Travelers might gather outside their lander, listening to the quiet sounds of a world that has never known a human presence. The ground beneath them radiates the memory of its sun, cooling slowly under the open sky. In this silence, the journey of centuries feels worth every moment, every challenge, every dream. And carried on that night air is the promise of hearing winds that have never touched Earth. Fact 82. Listening to winds that never touched Earth. The first time travelers hear the wind on an alien world, it may feel like a greeting, gentle, unfamiliar, and profoundly moving. Every breeze carries the signature of the planet, its temperature, its terrain, its atmospheric weight. Some winds might whisper softly through strange vegetation, while others glide over bare rock, humming low notes that resonate differently from anything heard on Earth. Because the air may be thicker or thinner, warmer or cooler, wind might produce tones and textures unlike our familiar breezes. It could move in long, steady sighs or in rhythmic pulses shaped by alien landscapes. Listening to these winds becomes a way of understanding the world, of sensing its mood, its history, and its quiet heartbeat. And beneath this living breath lies the vast stage of the alien horizon. Fact 83. Alien skyscapes and quiet horizons. The horizons of other worlds offer scenes as tranquil as they are mysterious. Maybe the sky deepens into shades of violet or copper, or perhaps it glows faintly with particles suspended in the air. Mountains might rise in smooth, curved shapes sculpted by forces unknown, or plains could stretch endlessly under the slow arc of a distant sun. At twilight, the colors might linger longer than on Earth, painting the landscape with soft, lingering light. The constellations above twist into new forms, their lines unfamiliar but quietly beautiful. Standing beneath such a sky, travelers would feel both small and connected, part of a broader universe that has always waited for them. And under that shifting sky, the cycle of water begins its gentle, alien dance. Fact 84. The water cycle of an unknown world. Every world with water follows its own rhythm, shaped by temperature, gravity, and the warmth of its star. On some planets, gentle mists may rise in long silver streams, drifting upward before condensing into delicate clouds. On others, rain might fall in slow, heavy droplets, landing with soft, resonant taps upon strange soils. Perhaps snow forms in unusual crystals, shimmering with colors unique to the atmosphere. Studying these cycles tells travelers how heat flows across the planet, how seasons change, and how stable the climate may be. It reveals where life might take root, how landscapes evolve, and how comfortable future explorers could be. Every raindrop or snowflake is a clue, a soft message from the planet itself, speaking of its nature. And beneath that cycle lies the deep, ancient shape of the land, carved by forces older than memory. Fact 85. Geology as a sleepy story of time. The rocks beneath a traveler's feet on an alien world hold stories written across eons. Smooth stones might reveal ages of gentle erosion by winds unknown, while jagged cliffs hint at past upheavals, slow tectonic rises, or ancient impacts from wandering debris. Each layer in the rock records a chapter of the planet's history, pressed quietly into mineral patterns and subtle shifts in color. Walking across such a landscape feels like stepping into a book without words, where the story is told in the curves of valleys and the soft shapes of hills. Travelers might pick up a stone and feel its cool weight, imagining the countless years it drifted through cycles of heat and cold. In this slow, patient geology, a world shares its oldest memories, and within those memories lies the tantalizing question of life. Fact 86. Life's possibilities in far-off places. Life elsewhere may not resemble anything found on Earth, yet the basic conditions that nurture it, energy, chemistry, and time, can arise in many corners of the cosmos. On a distant world, life might take root in gentle pools, warmed by starlight, or beneath ice sheets, glowing with internal heat. It could drift as microscopic organisms in the air, cling quietly to rocks, or shimmer in oceans beneath alien moons. Travelers would search for subtle hints, pigments in the soil, patterns in the light reflected from surfaces, or tiny variations in atmospheric gases. Life's signature might be delicate, requiring careful listening and patient observation. Discovering even the simplest organism would be a moment of profound stillness, a soft confirmation that the universe is fertile in ways we can only imagine. And before life is confirmed, explorers first listen for the softest traces left in the air. Fact 87. Biosignatures. Whispering in the air. A biosignature is any clue that life may be shaping a planet's atmosphere or surface. It might be an unexpected balance of gases, like oxygen paired with methane, or unusual patterns of light absorption, hinting at pigments used by alien organisms. These indicators are faint, often buried in data like a whisper in a vast, echoing hall. Sensitive instruments aboard a starship analyze the light passing through a planet's atmosphere, breaking it into subtle patterns that reveal its chemical story. When travelers detect a biosignature, they do not shout with excitement. They sit in quiet awe, feeling the weight of the discovery settle around them. Somewhere below, life may be stirring, breathing, or growing, and with each sign of possibility, explorers face the deeper question: how should such life be approached? Fact 88. The ethics of alien discovery. When explorers arrive at a world that might hold life, even in its simplest forms, they face a profound responsibility. Contact must be gentle, cautious, and guided by respect. The goal is not to claim or conquer, but to observe and understand without disturbing delicate ecosystems that have developed over millions of years. Even a footprint, even a sample taken too hastily, could alter something fragile. Scientists would design protocols that protect both the planet and the explorers. This means sterilized equipment, remote sensing, and sometimes choosing not to land at all. Ethical exploration becomes an act of humility, a reminder that humans are visitors in a vast universe filled with mysteries older than their species. And from this humility arises the promise of preservation. Fact 89. Preserving pristine worlds. Some planets may hold no life at all, yet their untouched beauty carries its own quiet significance. Mountains unshaped by human hands, valleys sculpted only by time, and plains that have never known a footprint remind travelers of the universe's purity. Protecting such worlds becomes a moral and scientific priority. To preserve them is to honor the story they tell, a story written in dust, stone, and starlight. Explorers might limit landings or designate vast areas as untouched sanctuaries. They may take only minimal samples or rely on remote probes that leave no lasting marks. By safeguarding these pristine landscapes, Humanity ensures that future generations can witness the same unbroken silence, the same untouched horizons. And yet, even as we explore outward, each journey gently turns our thoughts inward, toward home. Fact 90. Why exploration brings us home. Traveling to distant stars reveals something tender. The farther we roam, the more we understand our own world. Each alien sunrise highlights the warm familiarity of Earth's dawn. Each new landscape reminds explorers of the forests, oceans, and skies they once took for granted. In the vastness of interstellar travel, home becomes something deeper. Not just a place, but a feeling carried through time and space. Exploration doesn't diminish our connection to Earth, it enriches it. By witnessing the universe's diversity, travelers gain a renewed appreciation for the blue planet that nurtured them. Even as they stand beneath alien skies, part of their hearts quietly returns to the world that first taught humanity how to dream. And as these reflections settle, the final stretch of our journey turns toward philosophy, purpose, and the soft courage that guides us through the stars. Fact 91. Why we reach beyond our home. The urge to explore lies quietly in every human heart. Even in ancient times, people walked toward distant horizons simply to see what lay beyond. Interstellar travel is the grandest echo of that instinct, not born from conquest or urgency, but from a soft curiosity that asks, what stories does the universe hold? Reaching beyond our home is a way of honoring that question. Travelers who drift between stars carry this longing with them. Each mile crossed in the silent dark is a testament to the human spirit's gentle courage. Exploration is not about escaping Earth. It is about understanding the vast tapestry of which Earth is only one precious thread. And with every new discovery, that thread feels even more meaningful. From this yearning arises a quiet bravery, a courage that moves slowly but steadily. Fact 92. The soft courage of curiosity. Courage doesn't always roar. Sometimes it whispers. Interstellar explorers embody a kind of bravery that is calm and patient. The willingness to step into the unknown with steady breath and open heart. It is the courage to face darkness not as an enemy, but as a mystery waiting to be understood. Curiosity fuels this bravery. It invites travelers to observe without fear, to listen without judgment, and to learn without rushing. It teaches them to appreciate solitude, to trust the long passage of time, and to find beauty in quiet, distant things. This soft courage becomes the foundation of exploration, guiding each step and shaping each gentle decision. And as courage flows through the journey, patience becomes its constant companion. Fact 93. Patience as a traveler's companion. Interstellar travel unfolds on timescales far longer than human lifetimes. Even with advanced propulsion, voyages may stretch across generations, guided by slow acceleration, steady drift, and careful planning. In this vast timeline, patience becomes more than a virtue. It becomes a way of life. Travelers learn to measure their days not by miles traveled, but by moments shared. A quiet conversation in a garden, a new child born aboard the ship, a warm, artificial sunrise marking another cycle. They come to understand that the universe has its own pace, a gentle tempo that cannot be hurried. Patience teaches acceptance, serenity, and deep appreciation for each step of the journey. And from this patience emerges a unique beauty, the poetry of traveling slowly through an endless sea of stars. Fact 94. The poetry of slow voyages. Moving slowly through the cosmos creates its own kind of poetry. Without the rush of deadlines or the pressure of speed, travelers begin to see the universe in long, gentle strokes. A star that was once a pinprick of light grows brighter over decades. Nebulae shift, their colors softly as the ship glides past. Even the silence becomes part of the rhythm, a calm, steady pulse that shapes every day. In this slow voyage, time itself feels different. Days stretch into peaceful arcs, and nights deepen into velvet quiet. Small moments take on great meaning. A shared cup of tea, a plant sprouting in the garden, a new constellation glimpsed from a window. These details become verses in a long, drifting poem written across generations. And as this poetry unfolds, people find unity in their shared destination. Fact 95. The unity found in shared destinations. A starship crossing interstellar space carries individuals from different backgrounds, cultures, and lifetimes. Yet all aboard share one profound journey, the hope of reaching a distant sun. This shared purpose becomes a thread that ties their lives together, weaving community from diversity. Cooperation grows naturally, shaped by necessity and by the quiet truth that everyone depends on one another. Over years and generations, this unity strengthens. Storytelling becomes richer, traditions deepen, and communal rituals arise. Small ceremonies that mark the ship's progress or honor the memory of Earth. Through shared goals, people find comfort, resilience, and a sense of belonging. The ship is not just a vessel, but a collective home, drifting toward the same horizon. And as this unity settles into the heart of the journey, a legacy begins to form, one that reaches far beyond the ship's walls. Fact 96. The legacy of a star-bound species. Humanity's venture into interstellar space becomes more than a scientific achievement. It becomes a symbol of the species' curiosity and endurance. Each starship, each probe, each wandering generation leaves a quiet imprint on the galaxy, proof that life from one small world dared to travel into the vast unknown. This legacy is not carved in monuments or captured in grand events, but in steady persistence. Long after the first ships depart, their stories continue to inspire those who remain on Earth. Children gaze at the night sky and imagine the travelers far away, carrying human hopes with them. Scientists build upon the discoveries made across the light years. Even the smallest footprint on an alien shore becomes part of humanity's shared tale. And from this growing legacy, perspective begins to shift, gently, profoundly, like the turning of a distant star. Fact 97. How distance changes perspective. The farther travelers drift from Earth, the more clearly they see it, not with eyes, but with understanding. From light years away, nations, borders, and divisions vanish. The planet becomes a single, shimmering sphere, suspended in an ocean of black, fragile and radiant all at once. With distance comes clarity. Every argument seems smaller, every kindness greater, every life more precious. This change in perspective softens the heart. Travelers begin to understand that home is not defined by lines on a map, but by shared memories, shared origins, and shared hopes. Earth becomes a glowing reminder of beginnings, a cradle of stories and sunlight. And as the ship drifts deeper into the galaxy, this quiet realization settles warmly into every traveler's thoughts. And from this new vantage, hope itself becomes a guiding star. Fact 98. The hope hidden in every launch. Each starship that leaves Earth carries more than equipment and passengers. It carries a spark of hope. Hope that humanity can learn, grow, and reach beyond its limits. Hope that new knowledge will bring new wisdom. Hope that the universe, vast and ancient, still holds surprises waiting to be discovered with gentle curiosity. This hope is not loud or triumphant. It is quiet, steady, and patient, much like the ships themselves. It lives in the hum of engines, the tending of gardens, the laughter of children born among the stars. It shines in the belief that humanity's future can be larger than its past, shaped not by fear, but by exploration. And with every traveler who steps into the unknown, the story of cosmic travel grows richer. Fact 99. The endless story of cosmic travel. Interstellar travel is not a single event. It is an unfolding narrative that spans generations. Each journey builds upon the ones before it, weaving discoveries, mistakes, and triumphs into a long, quiet tapestry. As ships move outward in all directions, humanity becomes part of the galaxy's story, a species that listens, learns, and reaches with gentle hands. The story does not end when a destination is reached. It evolves. New worlds become stepping stones to others. New stars become beacons for future travelers. The universe, once distant and mysterious, becomes familiar in its vastness, a place where wandering is welcomed and wonder never fades. And at the heart of this ongoing story lies the final truth, that in exploring the stars, we discover who we truly are. Fact 100. Becoming citizens of the stars. In the end, interstellar travel is more than a scientific achievement. It is an invitation to grow. When humanity crosses the space between suns, it steps into a larger identity, no longer bound to a single world, but connected to the vast, gentle beauty of the galaxy. Travelers who look out into the deep night see not emptiness, but belonging. They realize that every star, every drifting cloud, every quiet planet is part of a greater home. Becoming citizens of the stars means embracing patience, curiosity, and compassion on a cosmic scale. It means carrying Earth's kindness into the unknown and letting the universe teach us in return. And with this final thought, our long journey finds its peaceful rest. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.